Your engine produces harmful pollutants such as nitrogen oxides, various hydrocarbons, and carbon monoxide that do not completely combust in the engine because the oxygen concentration in our atmosphere is not high enough to allow for a complete combustion to occur. Nitrous oxides are deadly to humans, animals, and the ozone, as well as being a more powerful greenhouse gas than carbon dioxide. Hydrocarbons are also toxic to people and serve as a greenhouse gas that is about twice as powerful as carbon dioxide.
So the way we actually deal with these problems is through a catalytic converter. And right here, you can actually see a catalytic converter underneath a truck. And what this piece is essentially a metal casing that connects on one end to the engine and on the other end, the exhaust. And on the inside, you can actually see here, horizontally cut, that there's a honeycomb framework that is inserted into the catalytic converter. This ceramic framework is then coated with insulants and then is coated once again with aluminum oxide. This aluminum oxide increases the surface area, which allows for more reactions to happen per second. Once this aluminum oxide coating is on, you dope the metal with the noble metals such as rhodium or palladium. And this is what actually does the reductive and oxidative cycles here. And so for the reductive cycle, we have rhodium, which will take nitrous oxides and reduce them to nitrogen and oxygen in the elemental forms. And so what happens is that nitrous oxides will flow through the catalytic converter in the first compartment and will coordinate to the rhodium center. As this happens, more nitrous oxides will flow through the catalytic converter, and then the nitrogen atoms of those will coordinate with the already bound nitrogen atom. This will then allow for N2 to leave and also allow for the other oxygen and the nitrous oxides to decompose into oxygen. Now, here we can see that the general formula of nitrous oxides in the presence of rhodium will simply go to N2 and O2 in a very efficient manner, about 98%. Here, we move to the next portion of the catalytic cycle, which is actually oxidative. Now, palladium works to oxidatively, completely oxidize hydrocarbons and carbon monoxide. Hydrocarbons in the presence of oxygen and palladium will react to form carbon dioxide and water. Additionally, carbon monoxide will completely combust to carbon dioxide in the presence of oxygen and palladium. Now this is how we generally provide very efficient means to reduce the smog and pollution coming out of internal combustion engines.
Without a catalytic converter, our atmosphere would be full of pollution, acid rain, reduced water quality, and climate change. This results from nitrous oxides reacting with other pollutants in sunlight to form a photochemical smog, which causes breathing difficulties. Nitrogen oxides and sulfur dioxide also form acid rain. Carbon monoxide and nitrous oxides have both been shown to be chemical asphyxiants, which means they have a better affinity for the binding side of hemoglobin than molecular oxygen. Carbon monoxide is much more of a concern than nitrous oxide for this specific case. This is due to the fact that even though rhodium and palladium reduce the activation energy, there is still a barrier to activation that is overcome by heat radiated from the exhaust gases. The heat needed to overcome this barrier is over 100 degrees Celsius. Possible solutions are to avoid halide salts when doping the catalytic converter. Additionally, large crystal structures have been shown to improve the rate of the reaction. Also, research into non-noble metal catalysts that can have better price-to-volume ratios would allow for a larger, reasonable catalyst loading.